After studying this module, you shall be able to know what are macromolecules, learn the various classifications of polymers, understand what is polymerization. Macromolecules are large molecules mostly built by joining smaller molecular subunits called monomers. The word macromolecule is a Greek word coming from macros, which means long or large. Was introduced by the German chemist Hermann Staudinger 1881 to 1965 to refer to large molecule of molecular mass of more than 10,000 AMU. These molecules are also called as polymers, where poly means many and mer means the structural subunits. In other words, polymers are large molecules of high molecular weight which are built by joining together a large number of small molecules, also known as monomers. The reaction by which polymer is formed by combination of monomers is called as polymerization. Polymerization is a type of chemical reaction in which two or more molecules combine together with or without the evolution of heat or elimination of water to form a molecule of high molecular weight. Thus, the starting material is also called monomer and the resulting product is called polymer. A polymer in its elementary form can be regarded as comprising of molecules of closely related composition of molecular mass at least 2000 AMU. Although in many cases the characteristic properties do not become obvious until the average molecular mass is about 5000. There is virtually no upper limit of the range of molecular mass of polymers, since giant three-dimensional networks may produce cross-linked polymers of molecular mass ranging in millions. For example, we can see ethene polymerizes to give a repeating unit, which further gives the polyethene polymer. Similarly, we have another example of hexamethylene diamine combining with adipic acid, which on polymerization gives nylon 6,6 plus N times water. Polymers combine the characteristics of both solids and liquids as it exhibits elasticity like solids and viscous behavior like liquids. Hence, polymers in solutions have unique viscoelastic, diffusion and colligative properties. Now we shall have a look at the classification of polymers. Polymer is a general name of large number of materials with high molecular mass. Polymers vary in the number and types of atoms present in their molecule, which give rise to different chemical structures, physical properties, mechanical behavior and thermal characteristics. Based on these properties, polymers may be classified in different groups as given in table. We can see that on the basis of origin, polymers can be classified into natural, semi-synthetic and synthetic. On the basis of thermal response, we have thermoplastics and thermosetting polymers. On the basis of mode of formation, we have addition and condensation polymers. On the basis of geometric structure, we have linear, branched and cross-linked polymers. On the basis of application and physical properties, we have rubbers, plastics and fibers. On the basis of tacticity, we have isotactic, syndiotactic and atactic polymers. On the basis of crystallinity, we have non-crystalline or amorphous, semi-crystalline and crystalline polymers. On the basis of polarity, we can have polar as well as non-polar polymers, and on the basis of chain, we can have hetero or homo chain polymers. Now we shall look at some of them in detail. For example, classification on the basis of origin. Based on their occurrence in nature, polymers have been classified into three types. Natural polymers. Polymers which are found to coexist in nature are called natural polymers. Examples of these kinds of polymers include natural rubber, natural silk, wool, DNA, cellulose, starch and proteins. We have semi-synthetic polymers. These polymers consist of the chemically modified natural polymers such as hydrogenated natural rubber, cellulosic, cellulose nitrate, methyl cellulose, etc. Synthetic polymers. Polymers that are chemically produced in laboratory are called synthetic polymers. These are also called as man-made polymers. Common examples of such polymers are polyvinyl alcohol, polyethylene, polystyrene, polysulfone, etc. On the basis of thermal response, we can have the following classification. Thermoplastic polymers. The polymers which get softened or plasticized repeatedly on application of thermal energy without considerable change in properties if treated with certain precautions are called thermoplastic polymers. Example of such polymers are polyolefins, nylons, linear polyesters, polyethers, PVC, sealing wax, etc. For example, the structure of neoprene is given. Thermosetting polymers. The polymers which undergo certain variations on heating and convert themselves into an infusible mass are known as thermosetting polymers. The curing or setting process includes chemical reaction giving rise to further growth and cross-linking of the polymer chain molecules producing big molecules. For example, phenolic resins, urea epoxy resins, dyeing, rubbers, etc. The structure of bakelite is given. On the basis of mode of formation, polymers can be categorized as addition polymers. These polymers are formed from olefinic, diolefinic, vinyl and related monomers. They are formed by addition of monomer molecules to each other in a rapid succession by a chain mechanism. This reaction is called as addition polymerization. For example, polyethylene, polypropylene, polystyrene, etc. For example, N-ethylene molecules combine polyethylene, which is a homopolymer. Condensation polymers. These are the polymers which are formed from the intermolecular reactions between bifunctional or polyfunctional monomer molecules having the reactive functional groups such as hydroxyl, carboxyl, amino, NCO, etc. On the basis of structure, polymers are of three types. Linear polymers. If the monomeric units are connected or joined in a linear fashion, then polymer is said to be a linear polymer. For example, a linear homopolymer and a linear copolymer is shown. Branched polymers. When the monomeric units are joined in a branch manner, then the resultant polymer is known as a branched polymer. Branched homopolymer and branched copolymer have been shown. Cross-linked polymers. A polymer is said to be a cross-linked polymer if the constituent monomeric units are joined together in a chain as following. We have cross-linked homopolymer and cross-linked copolymer. Now, we will see the classification on the basis of application and physical properties. Depending on its ultimate form and use, a polymer can be differentiated as rubber or elastomers. These comprise of rubber-like solids with elastic characteristics. In these elastomeric polymers, the polymer chains are joined together by weak intermolecular forces. These weak forces allow the polymer to be stretched. A few crosslinks are incorporated in between the chains which allow the polymer to regain its original position after the force is released, as in vulcanized rubber. Rubber is a high molecular weight polymer with long flexible chains and weak intermolecular forces. They exhibit tensile strength in the range of 300 to 30,000 psi and elongation at break ranging between 300 to 1000%. Examples are natural and synthetic rubber. Plastics. Plastics are comparatively strong substances with large molecular weight that can be molded with or without the application of heat. These are generally stronger than rubbers. They exhibit tensile strength ranging between 4000 to 15,000 psi and elongation at break ranging usually from 200 to 2000% or even higher. The examples of plastics are polyethylene, polypropylene, PVC, polystyrene, etc. Fibers. Fibers are long chain polymers characterized by crystalline regions resulting mainly from secondary forces. They have a much lower elasticity than plastics and elastomers. They have high tensile strength ranging between 20,000 to 1,50,000 psi, are lightweight and possess moisture absorption properties. For example, nylon 6,6. Polymers can also be classified on the basis of tacticity. It may be defined as the geometric arrangement or orientation of the distinct group of monomer unit with respect to the main chain or the backbone of the polymers. On the basis of structure, polymers are differentiated into three groups. Isotactic polymer. Polymers in which the characteristic and distinctive groups are arranged on the same side of the main chain are called as isotactic polymers. For example, the structure of isotactic polypropylene is given. Syndiotactic polymer. If the characteristic groups are arranged in alternate fashion along the main chain, then the polymer is said to be a syndiotactic polymer. For example, the syndiotactic polypropylene is shown. Atactic polymers. If the characteristic groups are arranged randomly in an irregular fashion around the main chain, then the polymer is said to be atactic. Such polymers have more strength, effectiveness and elasticity. The structure of atactic polypropylene is shown. Polymers may be categorized in different ways, and a convenient way is with reference to the manner of their preparation. The linking of a large number of small molecules termed as monomers with each other to a macromolecule or polymer molecule through chemical reactions is called as polymerization. It can be defined as the fundamental process by which low molecular weight compounds are converted into high molecular weight compounds. In addition to the structural and compositional differences between polymers, Florey stressed the characteristic difference in the mechanism by which the polymer molecules are built. Although Florey continued to make the use of terms addition polymerization, that is, polymerization that occurs by repeated addition process, and condensation polymerization, that is the polymerization that occurs by repeated condensation process along with the elimination of small molecules, in his discussion of polymerization mechanism. The current terminology categorizes polymerization into step growth polymerization and chain growth polymerization. The degree of polymerization is related to the molecular mass m of the polymer and is given by the equation dP is equal to m by small m, where small m is the mass of unit monomer. There are two broad types of polymerization reactions, that is the addition or the chain growth polymerization and condensation or the step growth polymerization. Condensation polymerization or step growth polymerization. In condensation polymerization, a chemical reaction in which a polymer is formed with the elimination of a small molecule of byproduct with lower molecular weight. The byproduct eliminated is called as condensate. The reaction can occur between two similar or different monomers. It is also called as step growth polymerization. In such reactions, each step yields a product which is again a bifunctional species, and the sequence of condensation goes on. Since each step produces a characteristic functionalized species which is independent of each other, this process is also known as step growth polymerization. The example of this kind of polymerization includes the formation of pterylene or dacron by the interaction of ethylene glycol and terephthalic acid. Addition polymerization or chain polymerization. In addition polymerization, two or more molecules of monomers are linked together to produce a polymer. In this polymerization, there is no elimination of any molecule. It is a chain reaction and no byproduct is released. It is obtained by linking together the monomer molecules through a chain reaction to give a polymer whose molecular weight is exactly an integral multiple of that of the constituent monomers, as in the case of polyethylene obtained by the polymerization of ethylene. Only a single kind of monomer is involved in this addition polymerization reaction. Therefore, polyethylene is a homopolymer which contains exactly same monomer units. Addition polymerization reaction is generally induced by light, heat or a catalyst for opening the double bond of the monomer and creating the reactive sites. A variety of alkenes or dienes and their derivatives are polymerized in the presence of a free radical generating initiator catalyst like benzoyl peroxide, acetyl peroxides, tertiary butyl peroxide, etc. For example, the polymerization of ethene to polyethene consists of heating or exposing to light a mixture of ethene with a little amount of benzoyl peroxide initiator. The process begins with the addition of phenyl free radical produced by the peroxide to the ethene double bond, thus giving rise to a new and larger free radical. This step is called as the chain initiating step. As this radical reacts with another molecule of ethene, another big size radical is formed. The repetition of this sequence with the new and bigger radical carries the reaction forward, and this step is termed as chain propagating step. Ultimately, at some stage, the product radical thus formed reacts with another radical to form the polymerized product. This step is called as the chain terminating step. The sequence of steps may be depicted as follows. In the chain initiation steps, the benzoyl peroxide ultimately gives rise to a phenyl radical. This phenyl radical reacts with a monomer of ethene to give another radical. The chain propagating steps involves the reaction of this radical with another monomer of ethene to give a large sized radical. In the chain terminating step, the free radicals can combine in different ways to form polyethene. One mode of termination of chain is shown as. Now, let us summarize what we have learned in this module. Macromolecules are large molecules mostly built by joining smaller molecular subunits called monomers. The reaction by which polymer is formed by a combination of monomers is called as polymerization. A polymer in its elementary form can be regarded as comprising of molecules of closely related composition of molecular weight at least 2000. Although in many cases characteristic properties do not become obvious until the average molecular weight is about 5000 AMU. Polymer is a general name of a large number of materials with high molecular weight. Polymers vary in the number and types of atoms present in their molecule, which gives rise to different chemical structures, physical properties, mechanical behavior and thermal characteristics. On the basis of heating, polymers can be differentiated into two groups, thermoplastic polymers and thermosetting polymers. In addition polymerization, two or more molecules of monomers are linked together to produce a polymer. In this polymerization, there is no elimination of any molecule.